All right, so let's get started. I see quite a few familiar faces as well as some new ones. So I'm very, very excited to invite you guys to this webinar today on 10xing your AppSec program with AI, where we'll do a deep dive into some of the key technical capabilities that Semgrep provides from an AI perspective using our AI assistant. Uh, just to introduce myself, for those of you who don't know me, I'm Nitin Nayer. I'm a staff solutions engineer here based out of London. Um, I've been pretty active in the AppSec community as well as OWASP, and work with our key customers based in Europe on rolling out their AppSec program as well as maximizing the value they get from the program. We have a packed agenda today. As part of our session, I want to start off by looking at the key AI philosophy, where SemGrep fits in, how Assistant works, what is our strategy there. I wanted to go through some technical detail with some real examples of how the three main AI assistant workflows work around noise filtering, recommendations, assessments, what benefits you can get out of that. And make sure to stay till the end of the session because I'm going to give you a sneak peek into an exciting new feature where we're starting to use Assistant on our SCA product. So please stay for that. And then finally, we have time for Q&A. So let's get started. Um, you know, it was, I think, almost 2 years, 2.5 years, 3 years back when AI became the rage with GPT coming on the play. And ever since that has happened, we've asked our customers, our prospects, our users this question, as well as internally, what's the most appropriate role for AI to play in the AppSec program with its current capabilities? I know some of you guys have participated in those discussions as well. And the way we see AI assistant, the use cases for AI assistants can be kind of factored into two categories. So one is what we call the low stakes, where it can be completely automated. And you think of this as like, content marketing, digital art, writing a review, email marketing, etc., where the stakes are lower, the precision is lower. And then there is high stakes use cases like tax prep or relationship management, where even the smallest change, even the smallest issue can lead to a big change. And in our view, what we want to do is focus the AI use cases, etc., when it comes to AppSec into that category in the green, where we have to be absolutely sure, absolutely on target in terms of what we are doing. And hence the strategy that we have chosen is we want to use the SemGrep engine, the Pro rules that you guys all know about from a static analysis perspective for its predictability, formal guarantees, performance stability, scalability, etc. Right? So you have that precision, the enterprise readiness. And then we are using the LLM capabilities, the Gen AI, in terms of things like what LLMs are good at, which is things like context aware understanding, being able to understand the code, being adaptable, where you can talk to it in like a natural language, as well as higher level reasoning. And based on that architecture and philosophy, the way we've come out is a best of both worlds. A lot of you guys have used this, you've seen the value of it, where we start with the world leading SemGrep Pro Engine and Pro Rules, where we have the deterministic findings, the best coverage, the best frameworks. And then we enhance that in terms of the findings or the vulnerability processing using the AI, where we pass it through things like the AI auto triage, which helps us determine, hey, is the finding a true positive or a false positive based on the context? The AI prioritization, where we use the AI to understand, hey, is this something which is impacting like my authentication service, which could break everything, or is this something which is related to a developer script or a migration script, which never would see production? And then finally, providing AI remediation fixes to make it as easy as possible for your developers to actually do things. Yeah. So with that context, we asked ourselves this question, we asked our users this question and say, hey, if you could hire 10 AppSec engineers tomorrow, how would we use that? And essentially the key themes or the key questions or the key findings we saw coming back was, um, I'd like to ask them to identify noisy rules and false positives. So that was one of the main themes was, hey, how can I use the AI to use its code context understanding to fix noise? Um, how do we do more proactive reviews and provide proactive fix suggestions where I don't want the SaaS solution or the AppSec solution to only tell us what's broken, what's not working, but we also want to provide fix suggestions which are specific where the developers can directly take it and push it out. And then last is how can we use the code context and understanding of my code base and understanding of the vulnerability to actually provide better context for prioritization. So those were kind of the three main ideas. And what we're going to do today is, and that's kind of what is kind of defining the Semgrep Assistant capability. So we start off again with the pro rules, and then we go into things like the AI auto triage, contextualization, fixing, as well as rule writing and management. And what we're going to do today in the session is we're going to focus a deep dive into the three key technical use cases. One is around reducing false positive with AI auto triage and memories. The second is highly contextual auto fix recommendations. And third is prioritization of findings. And of course, as I mentioned, there'll be a sneak preview into a couple of new features which are coming as well. Um, my goal is at the end of this, you guys are experts in these three use cases. You know exactly how it works, how you can roll it out to you, your teams, etc. But also understand at a business level how this would be helpful and benefit you and your AppSec program in making it more valuable. So let's get started with the first use case, which is reducing false positives with auto triage, right? So you guys said, hey, how can I make ask the assistant to identify noisy rules, etc., right? And so we're going to talk a little bit about that. But before we jump into the solution here around auto triage, etc., I wanted to spend time very quickly on what the problem is, right? If you've been following AppSec for the last 4 or 5 years, there's been the shift left, which is being talked about maybe even earlier, right? Shift left is going to be cheaper, faster, more secure. All the things will, all our problems will be solved. But the reality is what has happened with shift left is something like this, where developers are just getting inundated with lots and lots of findings. However, these findings don't have the right context, they don't have the right understanding of the code base, they do not have the right mitigation strategies. I have a code base where I'm using Flask and I'm getting recommendations for Django. It doesn't help the developers and it's leading to a lot of friction and a lot of challenges from a developer perspective, right? Um, Also related to this is the fact that there's a lot of false positives, right? We've done some studies, there's been some studies done in the industry as well, where in order for developers to adopt any tool, any guidance, etc., they need to get a certain threshold from a signal to noise ratio. And what I mean by signal to noise ratio is not just that the SAST finding which is being found is technically correct, it is, but also it's correct in the context of your code. So let's say, for example, you're using an internally based sanitizer. It's there in your code, but because it's an internally developed sanitizer, the SAST rule doesn't know it. So technically, the SAST rule is still flagging a injection style issue, but in the context of your code, it's not valid, and this leads to a lot of friction, a lot of loss of trust, and a loss of a relationship with the developers. And what we've seen is typically in order for the developers to act on something and do things, they need to get to this threshold of around 70%, etc., to get over the human cognitive bias. Otherwise, what happens is they just start ignoring everything. And the impact of this essentially is the effectiveness of your AppSec value, right? Of the program that you're rolling out. So you guys are rolling out an AppSec program. The goal of that program is to fix things quickly, earlier, faster. And the value of that is coming from these three key components. The first component here is the findings SNR, like I showed you, at the right thing? And if it's like at a 10%, you can already see that the value is down. Is the remediation guidance contextual and is it giving you the right things? And then thirdly is how much are the developers acting on it based on where the guidance is shown. And so hopefully you will see today how we can help you with Semgrep in maximizing all these three components using our AI assistant. Now let's jump into a little bit more technical detail and start looking at, what are the kind of the types of false positives and how SemGrep solves for it. And if you look at the types of false positives, you'll essentially look at two types of false positives. The first one is what we call a rule intent based false positive. So what this means is the rule is doing something natively and it's catching false positives independent of the context. And so you wrote a rule, the rule wasn't very high fidelity, and it's now starting to catch issues which it shouldn't be catching just because of the incapability of the rule or the engine. So SemGrep solves this and has been doing this for the last 4 or 5 years, as you guys know, based on our Pro engine and our Pro rules. So we have the deterministic Pro engine, which has advanced features like the cross-file analysis. It has taint analysis. It has an understanding of types. So is it an integer or a character, or is it actually a string which is capable of injection? And then we've also got our high fidelity pro rules. So these are the rules which have been written by our security research teams, and these teams are on a daily basis looking at it, running them, making sure there's no false positives. But we also do is we write the rules for specific frameworks and for specific languages. So we don't write an SQL injection rule for Python. We will write a rule which is tailored to the framework, say Flask or Django or Fast API, etc. And the key benefit you get from this is we are able to reduce significantly the rule intent false positives. And this is where SemGrep has already been known in the industry for so many years as the most high fidelity, low noise scanner, right? You guys know that. The second key component, which is what we're going to be talking a lot about today, is the rule was right, the intent was right, but in the context of your code base, in the context of the way you write code, in the context of the way you write your software best practices, the rule is triggering things. So again, the example could be you're using you have a internal application which is considered safe, and if you have a call generating from that application, right? Typically a SAST scanner will catch that. But because in the context that this is an internal safe application, it's a false positive. So that's where the AI assistant has become really, really powerful in terms of being context aware, being adaptive, and being high level reasoning capable. And now you might say, hey, great, Nitin, you're talking about all these good things. We've been talking about context for the last 10 years, but it's never really materialized. So what is different this time? How is Assistant doing this? And typically as an SE, this is one area that I don't think we do a great job of explaining. We're not just a wrapper which just takes the finding and sends it to GPT and says, hey, is this vulnerable or not? We are putting in a lot and lot of additional metadata, which makes our AI contextual aware, which is actually helping reduce false positive. And here are just some basic examples of that. So when we create the prompt, we pass in the relevant matched code as well as relevant lines of code above and below so that you can get the additional context. We will also pass in data that our security research team has created a big collection of findings on a per language, per framework basis of good code and bad code. So we actually push that. We will also push in the compiler context. What I mean by the compiler context is the full data flow analysis. So if you're looking at a SQL injection, we're not just passing the actual sync, we're actually passing the full source to sync path, including all the different functions which are being pushed, including the type information. So if there's a function in the middle that we know implicitly or explicitly translates a string into an integer, we know there's an implicit sanitization happening there, right? Those kind of things. And then we also pick up things like the triage history, memories, the commit information, the author's background, etc. And all this detailed technical information is actually pushed in as part of that triage chain. And you'll see how this really helps reduce false positives for us. But instead of me telling you that, what we've seen, we are always, internally, our founders talk about this principle, a core value of SemGrep, which is users are the judge. And what we have seen across 1,000 plus customers, over 600,000 findings across 90 enterprises, a 95% user agreement rate. And this is a really, really big thing. As well as a 96% agreement rate with our security research. And the reason why I'm really, really it's really interesting is the 95% rate is typically when things are going well, people actually don't give you a thumbs up. It's only when you always have a negative bias. So when things aren't going well, you'll actually get a thumbs down. And because what we are seeing here with our developer friends, with our users, our customers, AppSec, is we're getting a 95+% user agreement rate in terms of thumbs up and usage of those triage decisions or accepting those decisions. So again, really, really powerful, very, very successful way. And we've had customers who've told us, hey, once I enabled the AI assistant auto triage, we have not seen any false positives. Think about a SAST tool where customers are coming and telling you that is amazing. Really, really great to hear that as a SAST vendor. So now that we understand the context, what I want to go now deeper is into the actual how the technicals of how Assistant helps reduce false positives with the AI auto triage capability. And this is what the triage chain looks like. So, we talked about, hey, we put in a lot of context. We get this vulnerability, and then we do something called component tagging. We do triage, where we're getting the data flow traces, etc. We're getting guidance, etc. here. But let's look at it in a real example here, right? So here you can see I've got a code snippet. I'm creating this URL, which is coming from a request query, and I'm then passing it here into this post, right? So it is a standard definition of SSRF happening there. And that's great. Semgrep will automatically find this saying, hey, you're taking an untrusted user input, you're building a HTTP request, which can lead to an SSRF. That's great. But what's interesting here is the developer is actually using this internal library called util, and that library has this sanitizer function called validate proxy request. It's not JSoup or it's not cleaner, so it's not standard off the shelf, but it is there. And when a developer sees something like this, you start losing that trust. You start losing that trust with them. You start creating friction. And this is where this Semgrep assistant can be really, really powerful, right? Where we use the assistant to enable things like this. But so let's look at some of the common types of false positives we see due to the context. So the first one is, the data source, like we saw in the previous exam, in the data source is actually trusted. So the URL is constructed from data we control or foobar service is trusted. So this is typically the context that you as AppSec or your developers would have, but a standard SaaS tool would not. And this is where, again, we can use Semgrep and the AI assistant to say, hey, if the source of the taint is actually coming from this service, or if we control this, then mark it as a false positive, right? Or mark it as safe to ignore. And because we are passing that context of the taint, we can actually do this, right? It's not just sending the sink, we're sending the whole data flow there. The second one is tainted data is sanitized. So like we saw in the previous example, there was that call to a function called validate proxy request. We had other customers where this is from an actual FANG company where they use functions with the name cleanse, sanitize, or similar to indicate user data has been properly sanitized, and utils.clean is one such function. So again, using the AI to prompt this, and I'll show you real examples in the UI in a demo in like 5 minutes to actually show all these, how these created, how simple it is. The third example is the code not exposed to attacker. So the credentials are, for example, dev-only credentials, etc. Right? So they're never actually being sent to an attacker. Another one could be rule doesn't apply. So a lot of times if you're using fonts, etc., there might be an integrity check, but you can come here and say, hey, Google fonts are delivered. We are using Google fonts only, which do not require the integrity check. So hence do not flag integrity check issues. Code not first party, right? And then lastly, there could be a rule pattern bug, which you can also use to get benefit of the AI assistant memory. So again, lots of different examples. I'll show you some examples here, and you could then see how this is directly applied there. Very, very easy to create a memory. So what you do is you go into the platform, you just type in the basic example. You can choose if you want to apply it to all your projects or to a specific rule. And the other benefit with the memories is because it's written in NLP and it uses LLMs for context, it's also able to catch additional use cases as well. And I'll show that to you here. So just with that context, what I wanted to do now is maybe jump into a quick demonstration of in the platform. So here what you can see is the Semgrep dashboard. In the platform, we do have a couple of types of findings. So the first is what we call production backlog. So this is scanning your main, master, default branches. And in this, you can see what's already in this, right? The other thing that we as a company are really big on is what we call secure guardrails, which is, hey, how can we prevent issues from getting into your main master, into your backlog, into your security depth, where people are actually fixing them directly at the pull request or the merge request level. And so here you can see the guardrail activity. The blue shows the new things which have been opened. The green are the ones which are fixed. But what's really interesting is the lilac that you see here is the silence. So these are the ones which are automatically getting filtered by the assistant. So again, this is reducing that noise from your developers or to actually even see it. And we can have a look at one of these here very quickly. So here you can see a finding. It's a tainted Flask. You can see the user control data is going here. You can also see the full data flow, which is happening here as well. But what's happening in this case is the user input is being immediately passed through a cleansing function util.clean, which by our guidance means that the is meant to properly sanitize this there before it reaches an insecure deserialization sink, in this case being the pickle module. And hence it makes it lower right? So we actually show it to you here as AppSec. You can actually see this here. Also with our promise to the developers to say, hey, we don't want to show you noise. You have the option of actually disabling pull request comments if the assistant thinks it's noisy. So here you can see, although the rule was in comment mode, we did not actually leave a comment because the assistant thought that the finding was a false positive. So again, this is configurable, but what we're doing there is delivering on that promise of reducing the noise, reducing the false positives for your developer. Again, based on this very, very simple example here from a memories perspective. How do we create memories? So let's actually go and look at that here very quickly. So if I go here into this into the rules and policies and the assistant memories, this is where actually the memories are managed and created. One thing that we do, which is really powerful, is every time a developer, every time an AppSec person, anytime a security champion, an engineering manager engages with Semgrep, we learn from it. So if you think about your legacy SAST tooling or even SAST 2.0, right? Your developers were giving you feedback, your security champions were giving you feedback, AppSec was giving you feedback, but we were never learning that context. So where you started, for example, with one of our competitors 3 years back, you are still at that same point. There is no additional learning there. With Semgrep, what happens is as soon as any developer or any security champion or you guys as AppSec give us any feedback, and the feedback can either be here in the dashboard, right? So here in the dashboard, you can actually go and give us feedback by ignoring something. Or if you give us feedback here in the pull request comment, right? We will actually learn from it. And when we start seeing things come up, we'll actually start recording them. So here you can see on Feb 10th, one of our developers, myself, Nitin, we put in this triage comment in GitHub saying, hey, we are validating the request, validating the call domain from the user request. So this SSRF is a false positive. We got that. Semgrep has automatically now identified that, hey, I think this would be useful to create a memory for, and hence we actually create a memory here saying, hey, when domain validation or input sanitization is done, SSRF is a false positive, hence this. And so we've created this here. We still haven't activated this because we want to make sure that you as AppSec want to activate this. And you can also see what the impact would be. So here we can see if you want to enable this, you would reduce almost 600 false positives from your environment, which would be really powerful. And in the future, your developers would not get this as well. So again, really, really powerful way in which you can actually give them that capability of removing false positives and reducing that noise from them as well, right? Of course, you can go in and you can edit this. So if you wanted to make it change this, you could do that. You could either apply it to all the projects or you could apply it to certain projects, depending on what the scope you want it to be. You could apply it to all the rules, or you could apply it to, again, a single rule. And based on these changes, you can also see the impact which is happening here. So again, really, really powerful way in which we are giving you that control, right? to manage those, etc. And here, let's look at some examples of these. So if we go back to this example that we saw here, where the utils.clean was done, this was actually coming from this specific memory where functions with the name cleanse, sanitize, clean are used to sanitize things. Again, you can see here what the impact of this is. Really powerful. Now, looking at this again here, what you can see is we have, based on these memories, removed 4,500 false positives. The number of findings which have been analyzed and the number of pull requests, comments that we've removed to reduce the noise for your developers, really, really powerful. And hopefully you see the idea of, as you use the platform, as you're using it on a daily basis, you are actually making it better, making it understand your needs, etc. as well. Yeah. By the way, if you have any questions, feel free to drop them in the Q&A panel, and I'll look at them as we go through the session as well. So please feel free to do that. All right, so that's on the AI triage and the false positive reductions using the memories. Also wanted to kind of wrap up this session with real life business business impact. So we're working with a customer, a large Fortune 500 company, and they had a case where, similar to the previous example, they had SSRF issues show up. And this was because of the fact that these were false positive because of the way the URL was getting constructed. And so we added like two very simple memories here that you can see. And based on that, what we were able to do is reduce uh, the amount of false positives by almost 50%. So here you can see, based on their initial analysis, only 9% of the findings for this SSRF rule were true, and that was actually taken all the way to almost 50%. We've seen similar improvements in things like sanitizer or injection style issues in the order of, like, 50-60% noise reduction as well. So again, really, really powerful way. And as you saw, very, very easy to create those memories there. Very, very easy to just add them either manually or based on the developer feedback. And the prompting is essentially done in just natural language process, natural language. So you don't have to be a PhD or learn functional programming or need to do a course in like query languages, etc. So that was the first use case. If you guys have any questions, feel free to put them in the Q&A channel. I'm keeping an eye on that. Otherwise, I'm going to jump into the second one, which is around how to provide your developers with highly contextual auto-fix recommendations. So one of the other questions we got from people was, hey, SAST is great. You give us really good findings. They're high fidelity, low noise. But what we need also is the developers need some help in actually fixing the issue. So this is where Assistant really helps. We get the finding from our Semgrep scan. We actually prepare a solution, and you can review the fix in the platform itself as a developer. So even if you're not like an expert on really on things, you still have the ability to fix things very quickly. So here what you can see is directly in the pull request in GitHub or GitLab or Bitbucket or Azure DevOps, wherever you might be, we'll actually give you tailored guidance as well as an explanation of what the issue looks like. And what we have heard from customers in cases like this, we be able to save like 30 minutes per fix on average in terms of time that either the developers had to spend or the AppSec engineers had to spend to explain the issue with this. And again, with this, we've seen almost a 80% agreement rate. So let me jump into a quick demo of this capability as well here. So I'm just going to go here and maybe open up an example of this. So here what we can see is we opened a pull request, and what we've done is we have this logger, and what we're doing is in this logger, I'm passing this param, and this param is actually coming from a request object. And then in the logger, I have this here, right? So it's a standard log injection attack. Like we saw in the UI, you can see the full data flow. But what's really interesting here is we'll actually give you the real code. And we'll also give you two different options here. So based on the memories which have been created, we know that you actually use a secure logger library. Or if you don't want to use the secure logger library, you also have JSoup that you can use, and you can directly click from here. And then we have the step-by-step instructions on how to fix this. So you can see here, just from a just-in-time engagement and explanation for your developers, you can see here, replace the call with this if available, or you can use this. And otherwise, you can use JSoup from a sanitization perspective. So as a developer, I'm getting really contextual guidance here. I'm not just telling you to use cleaner or something. I understand your code base, and I understand the fact that you guys use secure logger. So I'm going to tell you how to use the secure logger. And also you can give us feedback if this is a false positive, right? So let's look at this one here, and let's look at the memory associated with this. So you can see here what we've done is, one, in the pull request itself, we've shown the developers what the issue is. So they don't have to do context switching. They don't have to go from here into another UI. And then we've given them the real code, which they can click commit suggestion, and an explanation of this as well. So if we go back here into the memories tab, this is the memory that my colleague David created, which says, hey, we use com.corp.utils.secure-logger as a custom log4j sanitizer. And what this does is it prevents logging of sensitive information because it's automatically sanitizing the user input so that you don't have to worry about it or use like a custom sanitizer like JSoup. And we can see here that we have actually given custom guidance to 159 pull requests and findings with this, based on this specific finding as well. So you can actually see this here as well. And this is again another example of what we do to help give contextual guidance. The other thing which is also interesting is, because Semgrep is deterministic, is fast, once we actually create this guidance, we will pass this guidance through the Semgrep rule again to make sure that the finding is now fixed. So we're actually helping reduce that noise further and not give them some guidance just saying this, hey, this will work, and then they run Semgrep again and it fails. So we're actually doing that additional step directly for them as well. So again, very, very quick way in which you can get these fixes, and then the ability to very easily train the model based on your usage to say, hey, by the way, I want to use the secure logger as opposed to using a standard logger online just to help me fix this as well. So that's on the remediation guidance side. Again, if you have any questions on this, either on the false positive auto triage, on the remediation guidance, feel free to put them in the chat. I'm keeping an eye on that. So if there's any questions, I'm happy to jump in there as well. Cool. The third use case that we'd heard from you guys about was, hey, how can you provide more context for better prioritization? And again, this is one where LLMs are really good. They're able to look at the code. They're able to see where the code is, where the function is, what the file structure looks like, folder structure looks like, the names of the functions, etc. And the key question we're trying to understand is, hey, what is this code doing? And is this like a vulnerability which is impacting a business critical capability like an authentication service or logging? Or is it like a migration script or developer script that will never even go into this? And so this is where, again, what we do is we use the prioritization that I showed you previously, looking at all that context associated by the file, the function, the metadata, etc. We pass that in, and we will actually mark it saying, hey, by the way, this finding you have here is related to user authentication, payments, etc., and not test scripts, etc. Right? So maybe another quick example here, a quick look here as well for this. So if I go here, what we can see is these different AI risk categories. Again, this is really powerful because you can see here we've got 32,000 findings here, right? We need to prioritize this. So the standard prioritization that you would do is, hey, let me look at criticals, highs, let me look at the high confidence, medium confidence, but you're still at roughly 6,000 findings. And now what we can do, or we're still at like 2,000 findings here. If I now put the risk assessment and I say I'm only interested in the high risk here, you can actually now see we are down to a handful of the findings that we need to really focus on here as part of our fix, right? So again, really, really powerful way in which we can actually get that information for you as well there. My apologies. Also, what you can see here is bear with me. Also, what you can see here is you can see some of the low priority findings as well. So if there are findings which are, for example, in the low risk category, like tests, etc., we can identify that. So giving you that ability to actually filter on the high priority versus the low priority findings as well. So any questions on the risk assessment use case? Brilliant. The other thing I wanted to kind of highlight here is, so here you can see, for example, there are these 18 findings which are matched on this user authentication. So you can actually go ahead and focus on these from a fixed perspective, right? You can go into the details page as well. So it'll actually show you what this is, why it is, etc. as well, right? The other thing I also wanted to show you was, whilst we've talked a lot about the capability, one key thing which is really important is the scale that the AI assistant gives you when it comes to this. Because what we've heard time and time again from all our customers, and we've seen this from, for example, a lot of the people who are on the call as well, right? I can see you guys. There's a ratio of 100 is to 1, 50 is to 1, 80 is to 1, 200 is to 1 developers to AppSec. And being able to manually go and triage 32,000 findings is just not possible. But this is again where using basic principles, simple things like what we've shown around the triage, the fixed recommendations, we can actually help you scale your offering, right? And the whole idea is to get you across that. Because a lot of times I talk to customers and they're like, they do the first scan, they're like, Nitin, what do we do with these 32,000 findings? And this is where the LLMs give you a jump start, where we can reduce this very quickly from like, um, you know, um, these 32 down to what we've seen off the bat using the AI triage is we reduce 20 to 30% false positives just off the bat. And then if you do some of that very basic things like the AI triage memories, we can get that down significantly by another 30 to 40%. As well as on the remediation side with the little bit prompting, etc., all those findings can now be sent directly into your Jira, into your pull requests, everything, etc. as well. And then all the actions we are doing is completely auditable either here in the backlog view or also in the pre-production view as well. So any of the findings which are marked as false positive, etc., you can still come and see them here in the pre-prod view as well. So brilliant. I see there's one question. How do you identify different data types or authentication methods? Is there... Data types, the Semgrep Pro engine is capable of doing that automatically for strongly typed languages like so Java, .NET, as well as Python, etc. We've got some stuff there. So we do that automatically. That's part of the Pro engine capability, Michael. Authentication methods, etc. We use a combination. So we use the LLMs to understand, but also what you could do is if you are using, one of the most common use cases for us is to create rules for catching on things like authentication, authorization issues. Is basically just creating a memory, or we can also write custom rules there. In terms of the identifying data for PI, etc., it's done through the AI automatically. You don't have to write any regexes or anything, etc. It's all done through the LLM. Cool. Brilliant. Another couple of things. This has been there for a while, but we do also use AI for rule writing. So if you go here into the editor, we do have the capability of writing rules using the assistant. It's really cool. You put in the choose the language. You put in a basic example, basic definition of what the issue was. You put in a good code, and it will actually generate a rule. It's really, really powerful. What I typically do now is whenever I get a request from any of my customers or POCs, I'll use this, and then I can always go and finesse it a little bit as needed, but really, really powerful there, which is built in. Another thing that we have is highly recommend, if you guys haven't tried this out, is we do have a MCP server. So if you or any of your developers are using Cursor, feel free to use this MCP server from and this would essentially insert Semgrep as a tool into your in Cursor. So really, really powerful to ensure as your developers are writing code, it's automatically running Semgrep rules on it, and they can get feedback directly in Cursor. So in addition to the IDs that we support, we also have the MCP server here. So that's all that is there already today. What I'm going to show you here now very quickly is a sneak peek. We are going to be launching this formally in the next few weeks, but I thought I'd at least show you guys this. So a lot of the focus from an assistant perspective till now has been on the SaaS side. Now what we're doing is we're extending that to SCA, and one of the biggest things we're looking at is upgrade guidance in terms of, hey, if I have a dependency and I'm asked to update the dependency because of the vulnerability, what is the level of effort which would be needed to fix this? So what you can see here is, in my repo, in my pom.xml, I'm calling worksook. And I can see here it's being impacted by this CVE, which has a CSRF issue. And the remediation guidance that you're getting from Semgrep or any of the tools is to go from 698 to 725, right? This is really challenging because it's a major dependency change. And so what Semgrep does now, using the Semgrep engine, but also using the AI, is giving you a full breaking change analysis. And the reason we can do this is because our SAST and SCA engines are running on the same thing, and we're able to extract information from your code base. We actually do a full analysis, and we can say, hey, by the way, be careful because this could be a big change. It's not just going into your into your pom.xml and pinning the version to 725. There are 9 functions who have changed their names, and these are the number of usages you have across your code. You have 3 function parameter changes, which means you now need to refactor code to take care of this. And there is 1 remove function, which now means you need to figure out how to do this again. And this is really, really powerful. We've gotten some really good feedback from our early private betas on this, around the ability to really help the AppSec and dev teams to understand what's the impact of that. Hey, just go ahead and update that dependency which has a vulnerability. Really, really powerful. If you guys are interested in knowing more about this, please reach out to us, give us a shout, and we're happy to kind of go into more details with you. This will be available, launched in the next few weeks, but just a sneak preview for you guys. Another thing that we do now is we'll actually be able to choose which ones are safe, and then directly from the Semgrep UI upgrade, open a PR to upgrade them. So you don't have to worry about your developers and going to them or opening a Jira ticket. You can do it directly, as well as automations where if we believe that it's high and critical, it's reachable, we can create a policy to say, hey, if the upgrade type is safe, i.e. there's no breaking changes, just go and automatically open a PR in the repository for your developers. So again, giving you a lot of that time and effort back so that you don't need to worry about that. You don't need to worry about doing all those things yourself. It is automatically done for you, and you're not wasting your time with your developers. And again, helps reduce that friction with them as well. So that's on the technical side. Stay tuned for this. If you're interested in more, please reach out to us. So just to wrap up, right? The whole idea around the AI assistant is to really build that trust with your developers. And hopefully I've shown you how you can do that today, in terms of, if you can tell a developer, if we can't tell you what changed, we won't show it to you, right? Developers always have remediation guidance. They have step-by-step guidance on how to fix things. We review the findings for false positives before showing it to the developers. We will only show you things which we know are true positives, which are critical to fix. And we will always prioritize the high impact, low cost breaking changes for your upgrades. How would that help increase, your developer trust, etc.? And the developers are never going to be asked to lead their coding environment. They can see all these findings, everything directly in GitHub. So that's the promise we are making to you and to your developers, in terms of restoring that trust, in terms of reducing that friction, making that really, really thing. Here's Kevin from Acashore, really good guy. He's been a big customer of ours. And I think the key thing here was the ability for Assistant to remember what it's told and automatically triage for me is game changing, right? As I mentioned, your old SaaS tools, your legacy SaaS tools, day one you start using them, and day end when you stop using them, they're pretty much at the same line. They haven't learned anything about your environments. But with Semgrep, every time you spend time with it, it's learning 1%. And that's the 1% rule, right? If you improve 1% every day, you get closer and closer to that ideal instance that you have. So really, really powerful uh, thing for you there. Here are a few resources for you guys. Also, just a shout, we will be at OWASP in Barcelona in 2 weeks' time. We have a big booth. We have some events. We have a paella making session just to do a little bit cultural thing. We also have a culture walk. And you'll get some emails, etc., from us, or feel free to register for that as well after the call. So if there's no other questions, then thank you everybody for your time. Really appreciate it. Hope you found the session useful. And if you are in Barcelona for OWASP, please hit us up. We've got a booth there. We've got sessions there. We've got some interesting after hours activities as well. So we really look forward to connecting with all of you guys there in Barcelona as well. Thank you.